Um, This is the last of the series of lectures on paleontology, and we have this morning Dr. Richard Hulbert, who just recently retired from, or as the collections manager of vertebrate paleontology at the Florida Museum of Natural History, where he supervised a professional staff of 4 and many volunteers, of which I used to be one many years ago. Dr. Hulbert authored or co-authored over 50 peer-reviewed publications in paleontological journals, demonstrating his research interest in mammalian evolution, the identification and classification of animals represented by their fossils. Although his research subjects ran the gamut from rodents to whales, among his colleagues, he is best known as a specialist on fossil horses and tapirs. He spent 22 field seasons leading crews of students and volunteers at digs in North Florida, an area that is rich in animal fossil remains, particularly from the Miocene, 23 to 5 million years ago. These locations are usually found serendipitously by farmers who are plowing their fields or in the lime rock mines of western Alachua County. Most recently, for 7 years, he led crews working at the Montbrook site south of Williston to excavate 5-million-year-old fossils. After decades of experience excavating, identifying, and researching the ancient animals of Florida, in 2001, Dr. Hulbert published the book titled The Fossil Vertebrates of Florida, of which I have a copy. Dr. Hulbert took his PhD in 1987 from UF and BS and MA degrees from the University of Texas at Austin. So Dr. Hulbert.
Thank you, Phyllis. Okay. Glad you could all join me this morning. Get the PowerPoint up. This intro slide is showing the Mount Brook site near Williston that Phyllis mentioned. And in fact, before I get going, I think maybe Dr. Block last week may have mentioned this as well. There are still volunteer opportunities to work at the dig. The fall dig just started last Sunday and will continue through mid-December and then on through the spring. Let's see. And so let's get going here. Forward. Forward. That one back. Oh. There we go. So Florida has an extremely rich vertebrate fossil record. In fact, it has the best vertebrate fossil record in the eastern United States for the last 25 million years. We have, just in our collection alone at the Florida Museum, we have well over 1 million vertebrate fossils in our collection, of which about 20% are mammal fossils. And we have well over 1,000 individual different fossil sites scattered across the state. This depth and richness of our fossil record allows us to answer these types of evolutionary questions. How has the geographic distribution of animals, and here I'm talking about vertebrate animals, but that could be applied to invertebrates or others, changed over time? How has the diversity of different groups of animals changed over time? When did major changes to the anatomy and ecology of these various animals occur, and what factors cause these changes? And then what are the different patterns, rates, and causes of natural extinction? And so these are some of the questions the professional paleontologists try to use the fossil record to understand. And we're not going to get into any depth in any of these. Some of the topics that I'll discuss will be sort of mentioned this in periphery, but this is sort of why paleontology to me is an important science, is we are the best people who can answer these types of questions. So first, just a very brief introduction about where fossils are found in Florida, because compared to some of the other talks you may have seen in this series by Dr. Block and Dr. Manchester, who typically work in the Western United States, I'm not sure you've seen what Florida paleontology is like. And it's a little bit different because our geography and topography is much different. And so the first group are natural occurrences, and these sometimes can be public collecting. And here you see, I'm pointing out the sides of this cliff here. This is Allen Bluff on the Apalachicola River in the Florida Panhandle. This is one of the few occurrences of what a geologist would call an outcrop of fossil-bearing rocks. So these well over 100 feet high of sedimentary rocks that not only produce fossils in certain layers, vertebrate fossils, but this is a fairly unique locality in Florida paleontology. There's also a layer that produces fossil plants, and there are several layers of fossil invertebrate, like shells of clams and snails. So just about the whole big picture of paleontology, everybody's happy at this one place, but that's about it. Most of the time, you find fossil plants in one place, you find fossil vertebrates in another. So this type of exposure, natural, is very rare in Florida. A couple other places where you can just find fossils on the ground or near the surface are on some of Florida's beaches. This one's Ponte Vedra Beach on the Atlantic coast. There are also beaches on the Gulf Coast, like near the town of Venice, where the wave action, particularly during storms, like our most recent storm of Nicole, the big waves come washing up. I'm sure many of you saw the videos of all those waves hitting and, crashing into maybe some of these houses. And so offshore, there are naturally occurring fossil-bearing sediments of a variety of ages, and during the storms, they erode out, and then the fossils are brought on shore, and then the beachcombers, like this woman here showing her sort of almost jewelry-like, those are mostly water-worn shark teeth. The other place where people commonly go and collect fossils is in rivers, and particularly the Peace River down in Southwest Florida. And in the rivers, they are these banks of the rivers are where the fossils are naturally occurring, but scattered. But then during floods, which again, the Peace River right now is in flood from the preceding hurricane, erosion is going on. Fossils are eroded out of the banks, transported with the flood waters, and then redeposited in a concentrated form. And so these people are scooping up with shovels the riverbed sediments and then screening them to find a variety of different fossils. So all of those places you can find fossils. That is not where we find most of our really scientifically valuable concentrated sites. Instead, we rely on man-made exposures. And these are generally found on privately owned land, either by individuals or corporations. And so the collecting is only allowed legally through the permission of the appropriate landowner. By far, the greatest source of these naturally occurring vertebrate fossil sites, as Phyllis mentioned, are in quarries. Locally, these are primarily limestone quarries. Here you see a big machine here. They quarry the lime rock to make cement and also for road bedding. They will actually go down, so they go down one level with this big machinery. The next step, they will drill holes through the rock with dynamite, shatter it, and then these machines will actually scoop up and go about 20 feet below the water table. This was probably around 2006. By the time we finished this site, this was like all water. But we are not digging in the lime rock itself. We are digging in an ancient sinkhole that had formed in the limestone, but it was only the mining activity which exposed these sinkholes. Now, it's not just limestone quarries. In other places in the state, there are clay quarries sort of north of Tallahassee. There are phosphate quarries and several major phosphate mines. And almost all these quarries, no matter where you are in Florida, are opportunities to produce fossils, and many important fossil sites and localities have been found by this activity. Also, construction activities can uncover fossil sites. Now, this one's kind of unusual. More normally, it's buildings, but in this case, in Marion County, they were constructing this practice racetrack. As you might know, there are many horse farms or ranches in Marion County, and many of them have these racetracks so their horses can learn to run around in a circle and how to do that. And those racetracks are perfectly flat. And so to form this racetrack, the ground surface here originally sloped from a high area to the right down to the left. And so the track was naturally about, anywhere from 15 to 20 feet below the original ground surface. And so they just had, and then on the other side of the track was a low spot. And so he just hired some contractors, and they got in with some road graders, and the job was to just sort of push the sediments from this side to the other side and fill that in to make it all level. As the road graders were going around the bend, they actually started slicing into fossil skeletons. Unfortunately, one of them was a big enough lower jaw of a shovel-tusk elephant, right about here, right in the middle. And they actually, and this was pretty rare for this to happen, they actually stopped the work. The landowner contacted us, and he agreed to let them move the machinery somewhat away as we excavated out several skeletons that were right on the track. And then later, once we actually moved and we dug on the sort of the infield side and found quite a few fossils. And then this was our last major excavation in the early 90s. On the outside, again, we found a couple more skulls of this giant elephant and another jaw and some other bones as well. So again, we have to do what the landowners say and where they want us to dig and things. And sometimes it's as simple as the farmers plowing a field. In this particular case, in the early 2000s, there was some farmers, last name of Tyner, just north of Newberry, and they had plowed, and you can sort of see the remnants of the furrows of the plow back here. And this is what the soil looks like in western Alachua County, and it's a very loose sand that's often not very thick and on top of lime rock. This whiter stuff here is the lime rock that's just a few feet below the surface. But other places right in through here, there was actually an ancient sinkhole that we were able in some places to dig down about 12 to 15 feet deep through these layers of beds of clay, again, to collect thousands of fossils. And again, if these landowners, they were the ones who discovered the fossils after they plowed, they almost insisted that we dig there. Again, that doesn't have to happen, but we were very fortunate that it did. Get forward. So the next part of the talk, we're going to do sort of a little time travel, and we're going to go through time in repeatedly looking at different groups of mammals. And I picked out sort of 6 stops for our time travel. We're going to start each trip at about 18 to 20 million years. And again, these time intervals I picked because they are particularly well represented in the fossil record. So we're going to start at about 18 million years ago. Then we're going to jump to about 9 to 10 million years ago. 4.5 to 5 million is our third stop. 2 to 2.5 million is our fourth stop. And then about 18 to 20,000 years ago, just at the end of the Ice Age. And then our last stop, what my baseline here, is Florida as it was sort of when the Spanish first came over, because that is the first sort of written records of what they found. And again, you might see these abbreviations elsewhere in the talk. So MA means millions of years ago, and KA means thousands. So the first group of animals I'm going to talk about, and these are the ones I study most, are the big plant-eating mammals, of which there are a number of different groups, but the particular ones that are least known in Florida, there are on the left here, the odd-toed ungulates or parasitactyls, to be more technical. In the middle here, we have the even-toed ungulates or the artiodactyls. And on the far right, we have the elephant, or more formally the proboscidean group. Each of these groups are known from fossils in Florida, and some of these things are still living elsewhere, like rhinos and tapirs are still living groups, but they're known from fossils in Florida. Other things like the elephant groups here, there are quite a few groups here that are completely extinct: mastodons and mammoths, gomphotheres. So we're going to start and look at some of these animals at 18 to 20. And so this is the pattern for a lot of the rest of the talk. I'm just going to show you a lot of nice fossils, give some highlights about them, and you can just sort of enjoy. Oh, no, I am going to do these graphs. Sorry, I forgot that. So here I have, although the color is a little different, this used to be orange and blue for the most part. But, oh, well, I tried. So the bottom in this, what to me looks more purpley here, is the number of species of odd-toed ungulates or parasadactyls at these 4 stops. And then the gold now appears to be the even-toed ungulates, and then the gray are the elephant ones. So you'll notice right off the bat, one major change that occurs is between 18 million and 9 million is the first appearance of proboscideans. In fact, there are no proboscideans anywhere in North America up until about 16 million years ago. That group had evolved in the old world and then dispersed to the new world around 16 million. So in our little time travel, they're going to first appear at the 9 to 10 million year old stop. The other thing I want to point out is the odd-toed ungulates. Again, most of this diversity is in the horses. There are usually just 1 or 2 possible tapirs and rhinos, but the rest are all horses, in particular here in the 9 to 10 million year old stop, where we have 13 different species living in Florida of odd-toed ungulates, for about the only time they're more diverse than the even-toed ungulates. And of those, I believe 11 of those are horse species coexisting, which is really remarkable because that's in today's world, there are fewer than 11 living species of horses across the entire globe. And here just in north central Florida, we have 11 species of horses coexisting. Otherwise, after that sort of peak, parasadactyl diversity gradually or precipitously declines, however you want to think about it, until 18 to 20 million years ago, 18 to 20,000 years ago, there was just 1 tapir and 1 horse species left. And then, of course, both of those go extinct, not counting the horses that the Spanish brought back with them. All right, now we get on to some actual fossil pictures. So again, these are things you'll always see on each of these charts, the time range. It's going to bounce around wherever it might be. So here on the top, we have 2 different kinds of fossil horses. Again, these are sort of in the middle stages of horse evolution. These are still relatively small compared to modern horses, particularly the one on the left, the Archaeohippus, is about the size of a small dog. Again, if you've been to our museum and seen if you think about the fossil hall, if you're familiar with that, it's the skeleton of the Archaeohippus is the one that's getting bitten by the bear dog being attacked. And so it's about the size of a good sized dog. The Parahippus is a little bit larger, and it's the horse that is eventually going to be the one. It's sort of developing teeth that are more advanced to start eating more grasses as opposed to leaves off of trees and bushes. On the bottom left here, we have a primitive member of the camel family. And on the middle bottom here is a small antlerless deer-like animal. And even though this is shown as the smallest, but it's actually the biggest of the animals, are rhinos. There are 2 different rhinos living in this interval. And on fossil rhinos, the horn does not typically fully preserve because it's made out of a hair-like material, but they have bumps on their nasal bones or other top skull bones. And if you see a bump like that, you know that particular fossil species of rhino had a horn. And so you see that bump there, that means this was a horned rhino. The other, even bigger rhino, this interval, did not have horns. And in fact, strange as it might seem, since all modern rhinos have horns, many fossil rhinos did not have horns. Okay, now we just jump in time. This is primarily fossils from a locality near Archer, Florida, and very abundant rhinos, 2 species of rhinos, incredibly abundant. This was the horse diversity peak I mentioned before. I could have filled this whole slide with horses. Many of them, it was my dissertation work. This particular one is one of several new species that I just named, Callipocelecistus. Then up here is a very interesting group, a member of, as you can sort of see from the name, from the camel family, but it is a particular branch of the camel family that evolved to become sort of a giraffe equivalent. That is, they evolved incredibly long neck vertebrae, incredibly long limb bones, and so their body shape and proportions are essentially that of the living giraffes of Africa, but a completely independent evolutionary steps to browse off the canopies of trees. And over on the upper right is another. So this is a completely extinct group of artiodactyls. There's no more members of this family alive today. But at this point in time, there were no true deer in North America. They were over in Asia, evolving in Asia and Europe. And so this thing was sort of a deer equivalent. And so it was a low crown browser, having teeth pretty similar to deer, but again, sort of independent of them. Forward. Now we're going to jump to 5 million years ago or so, and lo and behold, in the middle right, we now have the earliest, or one of the earliest true deer in North America. So again, in fact, this is relatively recent, so they hadn't been in North America much before 5 million years ago. So fresh off the boat, if you will, from Asia is true deer. Another thing I want to point out in here is we have multitude of horses represented by their teeth here, but the one in the middle is of interest because it is a one-toed horse. Of course, you can't see the toes from a tooth, but we know from other skeletons and things. This is a one-toed horse, so this is going to be probably the species that eventually gives rise to all of the modern horse equus. Dinohippus mexicanus, as its name implies, it really first discovered in Mexico, but now well known from the southern United States as well. But what's interesting in Florida, at least, is where out west on similar age fossil sites, you would get lots of one-toed horses and very few three-toed horses. In Florida, the three-toed horses represented here by Nanippus and over here by Pseudoparian are much more abundant in every one of our Florida fossil sites. And in fact, for example, at the Mount Brook site that we're digging now, which is the right age, about this similar age, we haven't yet found a single Dinohippus. We found lots of this guy and lots of this guy, not a single one of those. So just because one-toed horses had evolved in the late Miocene, that didn't mean they sort of took over and outcompeted all the other horses. Depended on the environment. All right. Now we jump ahead to 2.5 million years ago, and we still have both three-toed horses on the bottom right here. This is another species I named, Cormorperion emsley, after a friend of mine who found this specimen in a shell pit down in the Sarasota area. This is one of those occasions, again, so I'll just briefly mention this one. As soon as he found this specimen, which was part of a skull, I immediately know he had found the specimen I could name this new species out of. So we have a little catchphrase, or at least I do, that says that's a paper. So when I see somebody makes a discovery of that, I immediately know if you can write a scientific paper about that. One of the last of the three-toed horses. But up here, actually, in these age deposits now, one-toed horses, and again, so they have this one single median toe, and this is their hoof. There are no side toes that you would see, like, for example, in Cormorperion. They are also, so there's these very long, slender-legged llamas are now present, as well as this pronghorn antelope, which is actually relatively small, species smaller than the modern ones, and it has a big two-pronged horn, or horn core. All right, forward. Now we're going to go to the end of the good times for these big plant-eating animals in North America. Again, there's a lot of ones I could have picked for this particular slide. I had to pick a tapir because that's, again, what I study. One of the things I do. So up here in the upper right, this skull of tapir was actually found in the early part of the 20th century, was named as a new species by E.H. Sellards back in 1918. It is still one of the best specimens ever found of fossil tapirs. they named it after the town of Vero Beach. I still think that should be the town mascot, but nobody else follows me with that. But anyway, this is a common species in the late Pleistocene. Again, it goes extinct at the end of the Pleistocene, as does these really longhorn bison. This is a specimen from our Sarasota area. This mastodon tooth, that's from the Osceola River and the sort of the Bend of Florida. And this is a llama that's sort of from, where is that? Sort of Citrus County, Hernando County area, from a cave deposit. This is a llama. Yes, this is actually, if again, the llama skeleton that's on display in the fossil hall, this is the actual skull of that skeleton. So it's again another one of these long slender-legged llamas. Again, they persist all the way up. All of these four are examples of animals that go extinct approximately 11, 12,000 years ago, not just in Florida, but across North America. The cause of these extinctions is still widely debated among paleontologists and archaeologists, whether it's human related, is it climate change, is it some interaction, and there's some other kind of more crazy or out there theories. But that's our sort of now. So when the Spanish first arrived, there are documents of what they were finding and what the Native Americans they were interacting with. And so there were buffalo around, in the like 1500s, 1600s in Florida. But apparently these were not survivors before. So all of the older there's no evidence of bison bones from sort of 10,000 years ago to up to 600 years ago. So apparently bison, primarily when it did go extinct here in the East, but then around 1500, they expanded out into the Southeast and persisted for a couple of hundred years and before everybody shot them all. And then this is, of course, this is the introduced bison at Payne's Prairie, which they seem to have adapted to a very Florida lifestyle. And then, of course, I've got a cute little shot of some fuller deer. So the deer are actually the long-term survivors of the large herbivores. So they're the only one that has still persisted naturally up to the past that lived during the Ice Age of the large plant eaters. All right, so once you have a lot of large plant-eating mammals, you're going to have a large cohort of meat-eating mammals to prey on them. And that was much more true in the past than it is today, or even to the near recent future. And on the top, we've got a number of things that are sort of familiar to you. We have the wolf and fox family, the Canidae. We have actually two subgroups of the cat family. There are the ones that we're familiar with today, which we sometimes colloquially call them conical tooth cats to separate them from the saber-toothed cats, both in the family, and then we have the bears. Now, there are obviously smaller plant-eating things like weasels and things, but we're not going to deal with those. Then on the bottom, we have two completely extinct groups of carnivores. On the left, we have what are colloquially called bear dogs because they share some characteristics with bears and some with dogs, some unique. They're really their own family, and so a completely extinct group called the bear dogs. And then over here, somewhat related to cats, but again, in their own family. Many of them were saber-toothed, but not all. And so this is the Barbaraphilidae. Forward. So again, we're going to go back. Oh, no, we're going to see that graph again. Okay, so on the blue or the purple on the bottom here are the canids, dog family. These are also often one of the more diverse groups. They're sort of the steady groups here, always sort of persisting. There's typically always, or not always, but most of the time, there's a fox or one or two fox-like size things. There's sort of a coyote-sized thing, and then there's a wolf-sized thing usually. Now, interestingly enough, in the oldest record here, there is not a wolf-sized predator among the canids, but there is among the bear dogs. So the wolf ecomorph, if you will, is actually taken up by the bear dogs in this case. But moving forward, there's generally been a true wolf size of varying sizes, coyotes, and then every once in a while they spin off into other peculiarities. They tend to have a trend through time that they often will get ones that are trying to move into sort of what today you think of as the raccoon niche, being even more omnivorous, less carnivorous. And then occasionally you'll get canids that try to become more cat-like and be pure carnivores. Again, there are no cats at all at this time. This is an interesting time period in North America called the Great American Cat Gap. There were cat-like animals, not true cats, older. There were cats coming in, but there's a few million years where there are no cats at all. And again, one of the interesting things is there are other carnivores during that interval evolved, become more cat-like, getting more pure meat eaters. By our 9 to 10 million year old stop, we will have a saber-toothed cat as well as the Barbarophyllus. And then we have no bear. This is not a bear. This is the last of the bear dogs. So the bear dogs go extinct in this gap here in time. And true bears, which is this brighter yellow, there's no bear here. This should have been. Yeah, that's the Barbarophyllus. So these are different colors. The colors are more different on my computer, but how that's projector. So this is the true bears. So the bear dogs go away. The true bears evolve and disperse from Asia. It doesn't appear that this is an out-competing sort of thing. It just so happens this group was in decline. They were even more abundant further back in time. And so this sort of niche was available to take over. And then you see another sort of noticeable thing is the great diversity in cats in the late Pleistocene. Everything, now this is lions, big saber-toothed cats, down to the small bobcat. So let's just see some pictures of some of these things. So on the top here, we have the larger of the two bear dogs at this time period. So this is something called Anthision longiramus. And this is actually the smaller female version of this. The males were about twice this size. So really huge animals with proportionally very small brains and lots of jaw muscle. On the bottom here is one of the two sort of coyote-sized members of the true dog family. Again, so the key to sort of dog success is they sort of keep all the options up, and they have good teeth for cutting meat, but they also have areas in their back molars for crushing plant material or bone if they want to do that. So they're sort of very adaptable. Moving up in time, again, on the left, we have two members of the dog family, very different in size. We've got an early member of the gray fox genus here. And then this is, I didn't mention this when I talked about dog evolution, but in North America, we had at this time no true hyenas. And so there's a group of dogs that evolved to become bone-crushing specialists. In particular, they've increased the size of this particular tooth, and the enamel of the teeth is, the internal structure has changed to prevent the cracking of bones as they crush much more bones than your typical dog can do. And so if the bones, if the tooth enamels, oops, wrong button. I knew I was going to do that one time. Although I don't know why that went off. Did I hit something else? Okay. All right. So, okay. Back to here. So on the tooth enamel, if they take a harder bite than they normally should have, and a crack starts to develop in the enamel, the internal structure of the crystals in the tooth enamel will prevent that crack from propagating through the tooth and breaking it off. And so on the upper right, again, this is the saber-tooth predator of the time. Again, if you're familiar with our fossil hall, there are two of these attacking the rhino in these mounted skeletons in the internal fossil hall, whereas this is the long-legged true cat of the period. Forward. Moving ahead, again, sort of cats and dogs and bears. Skip that, try to keep on time. 2.5 million now. There's a lot of different sort of cat diversity. One of the, again, sort of interesting parallel evolution things or convergent things we see in cats is a parallel evolution of cheetah-like So very fast pursuit predators, probably not directly related to the cheetahs of the old world, although within the cats, they're somewhat closely related. Let's see, lights. So that's this guy right here. And we have an early member of the Smilodon group. This is a famous fossil that was collected at the Lysy Shell Pits in Hillsborough County, early 80s. The cookie cutter saber cat from the Hale area, the Newberry area, and then some foxes and wolves. Again, some other sort of, these would be some of the predators that would have faced the first humans when they entered North America at the end of the Pleistocene. So on the upper right here, we have this beautiful, complete lion's skull that was found in the Ichetucknee River in the early 60s. Although this predator is sort of known from scattered remains across Florida, it's actually really rare. Somewhat surprising, the most common of the big cats in the Ice Age of Florida is the jaguar. So we get many, many more fossils of jaguars than we do of lions or any other big cats. We also have this, what we call a short-faced bear, which is related to the spectacled bear today from South America. And then a variety of dog sizes from small foxes all the way up to the big dire wolves. And at least today, 500 years ago, when the Spanish came in, these are the big predators of the time: bears, panthers, wolves. Forward. All right, so the next group we're going to discuss are a little more peculiar one. These are what we call the xenarthran mammals. These are sometimes used to be called the dentates. And so there are three general groups. The xenarthrans are primarily, through their evolutionary history, a South American lineage. Throughout most of the Cenozoic, South America was an island. It was not attached to the other continents. And so the animals that happened to be there, once it's separated, evolved into their own peculiar little ways. And one of the groups that was there was the xenarthrans, and they were apparently at that point nowhere else in the world, and we don't get their fossils anywhere else. There have been some other things like pangolins that have been times thought to be related to these, but no more. So there are three major groups of xenarthrans. On the left here, we have the armadillos of today, as well as several extinct types that you're going to see. So they are characterized by this bony shell, which is actually, there are three of them on the animal. There's one covering their little head. There's one covering the body, the carapace, and then there's one covering the tail. So each one of these little things here is an individual piece of bone. And that's sort of important for their fossil record, because that means that when these animals die, they leave hundreds of these potential fossil things. And so for their fossil record, often all we find are these pieces of bone, which we call osteoderms. So fossils of their limbs and their skulls and other parts are present, but they're much rarer. The middle one I just put in for completeness. Of all of the three groups, this is the one that never made it to the United States. They did get as far north as Mexico, but for whatever reason, we got plenty of ants here for sure. You could probably use some anteaters around your backyard or something. But they never, maybe because of climate, they never made it north of Mexico. And so we don't have to worry about them for fossils here. And then there's the sloths. Of course, there's the tree sloths, these very peculiar looking things, very slow moving. But in terms of fossils, what we're more interested in are these four different families of extinct ground sloths, which are much larger than today's tree sloths. And forward. And again, they have a much narrower time interval here in Florida. So there are no xenarthrans known from the 18 to 20 million year range zone. And historically, there were none present when the Spanish arrived. Now, that might surprise you because, of course, there are armadillos around today. But you guys are old enough to, or maybe your parents, if you're native to Florida, know that armadillos, 100 years ago, there were no armadillos in Florida other than in little zoos and menageries. They were at that time working their way up from Mexico into Texas. So they were dispersing. So this wasn't, because it was occurring in the 20th century, it was a very well documented, fairly natural dispersal, except here in Florida, there were some fairly well documented escapees from these, little neighborhood menageries. And so some of them got out of those and then began breeding in the wild and filling up Florida with armadillos. And then so the ones coming from the west met the ones that were in Florida. And so there's now continuous distribution of armadillos throughout the southeast. And as global warming occurs, temperature gets warming, they will be moving up into the northeast to populate their highways with little carcasses. Now, let's go here. So 9-10 million year old, this is the sloths. So this is sort of somewhat peculiar, but there are a few animals that were able to disperse between North and South America around 9 to 10 million, even before the two continents firmly connected. But there were some islands sort of dotting the way between the two, and two different kinds of sloths made it into North America at this time interval, and both of them are known from Florida. And the sloths are sort of the most successful of these three groups. As you can see, they get, at least in terms of diversity, eventually they'll become much more diverse in the 2 million year range. The armadillos and the various types of armadillos, panthers, glyptodonts, they don't get into the United States and North America until around 2.5 million years ago. Much greatest diversity in the early Pleistocene, a little less so in the late Pleistocene, but all three groups still persisted. All three go extinct after the end of the Pleistocene. Forward. I'm going to show these in a little, somewhat different way here. So here are the sloths of about 9 to 10 million. Again, there are no armadillos at this time. There's a smaller one called Pliometanastes. Both of these have somewhat complicated names. Pliometanastes, megalonychid. Here's like one of the digits. You can see they're characterized by these big claws. And again, this is from the fossil hall at the museum on the right here. This is the Thinobidistes, which was originally found from Williston area and later found other sites in Florida and elsewhere. 4.5 million, actually, there's a sort of a downturn in sloths, and there's just this one type of sloth, and we don't have a lot of great fossils, so I was sort of stuck with just showing you a couple of bones of it just to say, okay, there were sloths at this time. One kind of sloth. Okay, so at this 2 meter interval, I'm showing, these are the first of the, all of these pictures are the same species on the whole slide. So this is the true armadillo-like sloth, and this is this really remarkable skull that was nearly complete skull that was found near Inglis, Florida. This is what their lower jaw looks like with these little peg-like teeth. The modern armadillo has even simpler, smaller teeth than this. So these guys may have been more capable of eating small animal prey, like rodents and lizards and things, one of the leg bones. Forward. So this is the smaller of the three armadillo-like things, and this was the biggest. And so in the upper right here, you sort of have, this is be a regular size armadillo, and this is a glyptodont. The glyptodonts are different from the armadillos in that their carapace doesn't have those bendable sections in the middle. So it can flex a little bit, but it's pretty solid. So they're not bending around the way armadillos can. And so each one of these individual little things here, this is an individual bone that are sutured together sort of in a mosaic tile-like fashion. And they have this pattern here that is fairly sort of like flower-like, or people thought it was flower. So paleontologists call this a rosette pattern. This is what their teeth look like. So very interestingly, these are definitely plant eaters. They have flat grinding surfaces. Because their teeth lack enamel, they would wear down very fast, so they have ever-growing teeth. The teeth never wear out. They have also evolved, and you can sort of see it here, these different colors. Their dentine, they have different types of dentine of different hardnesses, so that this middle section is raised up as like a ridge, and this outer section is also raised up. So when the upper and lower teeth grind against each other, these act as graters to really crunch up the plant material, and they are thought to be grazers, and so it's appropriate that they are out here in this grassland. Next is the pamphotheres, or sometimes called giant armadillos. Again, this is a remarkable complete skull that I actually helped collect back in the late 80s from near Newberry, Homzina floridanus. And this is the lower jaw that probably goes with it. These are some of the more typical fossil bones from the shell or the carapace. This is what you get at most fossil sites. Lots of these. You don't get a lot of these. And then in terms of sloths, again, if you've been to our museum and you've seen the giant sloth in the corner, this is the actual skull that what's on display is a replica of this. And that's why it's sort of reconstructed in a few places. And again, this is what one of its digits looks like. This is something called a rematherium. And just to give you a sense of proportions, here we have an artistic representation of a rematherium and a modern tree sloth, and then sort of in the shadows, a human for scale. So quite a bit of a large animal, particularly when it presumably reared up on a sort of a tripod fashion with its broad tail and its two sort of ponderous legs. It could reach up pretty high in the branches with its relatively long arms to tear down branches to get more leaves to feed itself. Now I'm going to move quickly into marine mammals. There are three major separate evolutionary transitions from terrestrial mammals to marine mammals over the course of the Cenozoic. There are on the left the whales and dolphins, which are derived from artiodactyls or even-toed ungulates. So we have a transition from a primarily plant-eater group, and although there are some omnivores like pigs, to the more carnivorous whale and dolphin group. Among the herbivores, we have the dugongs and manatees, which are more closely related to elephants. And that's their sort of most closest living ants group. And then on the far right, we have the seals and the walrus, which this example here, which are an offshoot of the carnivores, and particularly ones closely related to bears and raccoons. And so these are both of these occurred in the Eocene, the transition around 45 million years ago. The seals and walruses is, I think, more close to a 25 million year old. So the transition is not quite as complete in terms of marine life, but close. Okay, forward. So these are just all time periods. So this is just a smorgasbord of whale fossils from Florida. On the far left are some of the earlier whales from Florida, the Eocene whales. We have a vertebra and a tooth from Eocene whales. This long-snouted dolphin, this particular species we have fossils of it from Gainesville, the Gainesville Creeks. You often will get isolated teeth or ear bones. I know this one is from the Gainesville Creeks of this species. But we did get one, not this particular one, but one fairly complete skull out of the bank of one of the Gainesville Creeks. But more commonly, because the fossils we get of whales are the ear bones, and if they have teeth, the teeth. The ear bones are much sturdier than the rest of the skull, so the animal has this really solid bones. This is the inner ear, so the semicircular canals are inside here. This is what we call the bulla, this bony structure underneath the petrosal here. And so most whale fossils are going to be these two things, or teeth or vertebrae. On the far right here, we have an ear bone of a baleen whale, roughly about 3 to 4 million years old. This is the back of a lower jaw of a baleen whale. The baleen whales, these are coming out of the Sarasota area. They are also actually come out of the Jacksonville area, some like in the St. Mary's River, places like that, or some of the quarries in Northwest Florida, but also these are found, again, locally, but also in the phosphate mines in Polk County area. These are found out of the limestone, so places like in the Newberry and Marion County where they mine the limestone, these are found in the Much more numerous in terms of fossils from Florida are the dugongs and sirenians. I don't have a lot of great pictures of these, but on the left, again, we have some Eocene representatives. So these are things found directly in the limestone. So it's a little bit rarer. But what's much more abundant are through the Oligocene and Miocene is sort of the age of dugongs, particularly in Florida. And so this is one example of a relatively complete skull that was found near White Springs from the bed of the Swanee River during a sort of low water phase. And this is a close-up of the teeth of this thing. This is what their teeth look like. And in fact, in that sort of stretch of the Swanee River near White Springs, there are 3 different genera of dugongs that live. And one of the major differences is in how far deflected this snout goes. And it's a little hard to tell. They actually have like a little, this one has a little tusk, but they have like, there's like one with a little tusk, one with a medium-sized tusk, and one with a really big tusk. And these guys are feeding on seagrasses. If you've ever seen, they are more marine and seagrass feeders than the manatees. And so they will actually go to the beds of the ocean floor and use these tusks to scrape up the root system, the rhizomes of the seagrasses. And so they have they're ecologically separating themselves through this thing on what sort of things they will be eating. So their fossils are extremely abundant in Florida, skulls less so, but you particularly get a lot of ribs and vertebrae and isolated teeth. And finally, I don't have, again, not a lot of pictures of seals and walruses. You'll see a few things. The unfortunate Caribbean monk seal used to be native to Florida. Again, this is something, unlike the armadillo, it's sort of the reverse. This is something, its extinction was fairly well documented in the mid-20th century. So up until around 1950, these were still occasionally found in Cuba and some of the Caribbean islands, a little bit more rare in Florida, but they used to live in Florida on both the Gulf side and the Atlantic side. This is the Caribbean or sometimes West Indian monk seal. There are 2 still living species of monk seal. Both of them are heavily endangered and probably close to going extinct, particularly the one that lives around Hawaii, the Hawaiian monk seal. And then there's another one that lives in the Mediterranean. And again, because of pollution and commercial fishing and things, they're both on their way out compared to other seals. But we do get their fossils in Florida. So these little X's have shown where we have found fossil monk seals in Florida, mostly down here, but there's one record of a fossil in the Osceola River. And then there are also records in some of the Native American where they quarry out the middens with the Native Americans, their garbage pits. So the Native Americans were hunting them on the beaches of Florida as well. Okay. And then perhaps the most surprising occurrence of a fossil, when I talk to people about fossils in Florida, one of the things that surprises them the most, even more than, say, lions or llamas, is walruses. Now, one thing I want to emphasize is this particular kind of walrus was not adapted to extremely cold environments and living on icebergs and things. Elsewhere, it lives in places like the Mediterranean, or lived in the Mediterranean, coast of England and Belgium, and on the Atlantic side of things from Virginia to Florida. And some of its relatives are known in the Pacific Ocean, in particular over in Japan. So this group is thought to have evolved in the Pacific and then dispersed to the Atlantic through what is now the Central America, but was the open seaway at this time still. The tusks are the most common of the fossils we get. This is a fairly complete one. These are actually even bigger than the tusks of the modern walrus, quite substantial things. So each like a couple feet long in particular. One peculiarity of walrus tusk is, again, like these do not have any enamel. So most of what you're seeing here is dentine of several varieties coated with a layer of cementum. And this is sort of a broken cross section. It doesn't show you up well in this, but there's like 2 different layers. There's an inner layer of a different kind of thing called osteodentine, which is what you hear. It sort of looks like popcorn almost. And then there's an outer layer of dentine, the orthodentine, and then an outer layer of the cement. And so this particular structure allows us to identify even fragmentary pieces as walrus tusks. And where would we find these things in Florida, you might ask? Well, here. Some of them as close as the Jacksonville area, even washed up on the beach, but more often in these quarries and things. And then there was another quarry here, and then the Bone Valley phosphate mines here, and then some of the shell pits along sort of Sarasota, Hillsborough County here. And that is where we have found walruses in Florida. Again, they go extinct around 2.5 million as things cooled down, as we really got into the Ice Age. And it's because these were relatively a warm water thing. They don't go. And I believe this is the last slide. If I'm correct. And it is. Okay. So in the remaining time, I'd be glad to answer any questions you might have about what I showed you, or any other question you might have about Florida paleontology. Yes.
Where do the alligators come in?
Where are the alligators? Well, this talk was about mammals, but we actually have alligators going back even before 18 million. In fact, I'm working on a paper with some people on some alligators that go back maybe close to 30 million. The earliest alligators are actually, again, if you saw Dr. Block's talk, you might go in the Eocene and Paleocene. It was much warmer. And so there are actually early alligators and early alligator relatives in places like the fossils coming from Nebraska and Wyoming. And so that's where we get our first of the alligator tree. Again, there are crocodiles and alligators going way, way back into the Mesozoic when there were dinosaurs. But in terms of the family, alligator family, they start in the early Cenozoic. We start picking them up in the Oligocene epoch here in Florida. Initially, they start out fairly small, but then get larger through time. But they are pretty consistent members of the Florida fauna, pretty much as long as you have fossils that are representing water habitats from anywhere from, and large animals, from 30 million years to the present, we have alligator fossils. We have a group of students who are actually doing a research project on our fossils, but they've determined, again, they started off just looking at the Mount Brook fossils, alligators, which they figured out was a new species, but that branched out into looking at others. And so, although the differences between them are subtle, they are significant enough that they think it's not just one species persisting through time, but there are many successive species, perhaps related to the fact that when the sea level rises, and then much of Florida, coastal Georgia, Alabama, Mississippi, where their sort of habitat gets underwater, and then they're sort of shoved back up into the further north, and then sea levels come down and they sort of repopulate. And those things may have triggered speciation events.
Thank you. We do have a question on Zoom, Phyllis. Is that okay? Keith Berg, go ahead.
Yes, the question has to do with how one makes decisions about whether a fossil is coming from a new species. Presumably, the process of evolution is, terribly gradual one. And so do you find species right in the middle where you can't decide if it's one or another, or to just suddenly something new appear that you can't find the in-between ones?
Well, it would certainly depend on the fossil record of the particular animal and whether you have this is more commonly what Dr. Block would have seen last week, where he has, maybe several hundred feet of section and thick, and he can sample through that 100 or more feet of section and trace the lineages much more completely. Here in Florida, there are more gaps in time, and so we don't know really is the transition if you got, one population at time A and another population at time B, and there's differences, whether that's a gradual change or really rapid change. So both kinds of speciation, you see gradual change and the rapid punctuated equilibrium sort of changes. How you determine whether something is a new species or not is always for fossils is always a judgment call, because obviously you can't, for most of these, you can't test the DNA because they're too old. You can't obviously tell if they were reproductively isolated from one another. So you have to make comparisons with related modern animals to see what is the amount of individual variation you would expect within a population, compare it to what you see between two or more populations of fossils. And so paleontologists like myself rely heavily on comparing, the variation I see in modern mammalian species. Say, if I'm looking at fossil horses within the zebras and other samples of modern zebras or tapirs or whatever, and if the differences are substantially greater than what we see in a modern species, then you can say, okay, these two things must be two different species. It's not, again, it's not cut and dried. You may recall that, I think it was just last year, maybe early last year, a group of paleontologists came out and said, no, that T-Rex is actually 3 different species. And more recently, although it didn't get quite as much publicity, there was a pushback, and another group of scientists said, no, you're wrong, it's all one species. And so there is, as we get better and better fossil records, we accumulate more specimens, better specimens. We're always sort of testing ideas about each other, but there are definitely controversies and disagreements among paleontologists about whether 2 different populations belong maybe to the same but closely related species or one single species. And so, it's not, perfectly clear.
For an example of that would be what we call mountain lions, which are related to Florida panthers, but in the West we call them mountain lions, and the lion species that you pointed out. Now,
Yeah, the Panthera
is that the same thing as what we call mountain lion? What's the distinction? Is it like an African lion? Or?
Well, that's fortunately one that its range was up into Canada and Alaska. So they actually have the DNA of it from some fossils. And so they've sequenced a number of the genes of that and compared it to the cave lion that was in Northern Europe in the Ice Age, as well as the modern lions from India and Africa. And there's been enough difference in those genes to say that they are probably a separate species. Although, because there was a debate among paleontologists whether it was just one big species from Africa all the way through the America and just different subspecies. And so if you go back 20, 30 years ago, you can find papers, people saying that. The DNA evidence suggests that these things really, there's a difference, there's enough difference in the DNA sequences to say they were distinct species, but very closely related. Because there was also debate, and there were some people who looked at the what we call the American lion and said, no, it was a big jaguar or something like that, or it was a big tiger. Again, the DNA shows that it's a lion, more closely related to lions than any of the other big cats.
Well, that brings to mind this dispersion that happened more than once from Eurasia into North America, which presumably resulted because of sea level declines and came across the land bridge from northeastern Asia into the Alaska area. Is that
Yes.
the
That
thought?
was, yes. So in fact, there were dispersals of various groups of mammals throughout the later half of the Cenozoic, in both directions, although it's mostly going from the Old World into North America. So some of the things I talked about, like the proboscideans or the bears or the cats, are animals that dispersed from the Old World into North America. A few things that are North American in origin are the camels. So they originated in North America and dispersed to the Old World. And then actually the dogs, wolves, dispersed to Asia and then to the rest of the Old World. But then ironically, within that, the modern gray wolf lineage evolved in the Old World and then dispersed back into North America. And so there's sometimes that sort of back and forth. And then the most famous of the New World to the Old is the horses. So our 3-toed horses several times dispersed into Asia, as well as the 1-toed horses evolved here in North America and dispersed into the Old World, and then ironically going extinct in the New World. And then, so when the Spanish arrive, there are no horses native to North America, and they have to sort of reintroduce them. And there's a famous Far Side cartoon about that.
I used to drive a lot in Florida years ago, and we noticed that we were always running over the armadillos. And we just always said, well, the armadillos don't have good eyesight. Is there anything to explain that?
Well, yes, you're definitely correct. They do not have good eyesight. They're essentially their natural way they cope with when they see something coming at them that is maybe bigger than them and something they should be afraid of, is actually to stand still. And then because they're going to rely on their armor to protect them, particularly if they're in a place where, if they're in a place where they can dig fast, they will try to dig down because they're good diggers. But if they're just sort of relying on their shell to protect them. And also they have this really bad habit of jumping up in the air when things get really close. So a lot of times the cars will naturally want to pass over them if they're, or a big truck, and they actually jump up and get smashed that way. So they're just a very, again, and their relative brain size. Well, one of the differences between those three xenarthran groups I talked about, they have some physiological and neurological differences between the other placental mammals. They're a fairly early branch, and so they have their physiology is somewhat primitive in terms of regulating their body temperatures, and also they don't have very big brains compared to the rest of us. And so this is the combination of those things means they clearly have been around cars now for many generations now, and they don't seem to recognize because now squirrels are much more intelligent, and even some of them still just want to zip, and then they just. But you do see more and more. It seems to me you see more and more squirrels crossing streets, but if they have wires, telephone poles, electric poles, you see a lot of them do that these days. Anybody? We're going to run out of time pretty soon. So.
Is it known how old armadillos are, and how do scientists date the fossils you find?
Okay, so we're primarily dating the rocks that the fossils are found in. So the armadillo group is an ancient group in South America. They go back at least to 35, 40 million years ago. But you would do the dating, you would find crystals of minerals that contain certain elements, in particular uranium is one, but also potassium, which is a more commonly found element, which there are a naturally occurring radioactive isotope of potassium. And so if you have, for example, if you have some granite and you sample out the pink feldspar, which is potassium feldspar, sample crystals, you can put it in a very fancy machine and it will tell you when that granite crystals formed. And you can do that similar things with volcanic ash beds and lava flows and things like that. And so if you're in an area where you have a variety of volcanic eruptions, you can, place dates on various ages of rocks. And then there's another thing called paleomagnetism, which correlates with the things. And so again, if you have long sections. So geologists, when we're talking about the age of the fossils, it's primarily being determined from the age of the rocks they were found in.
Got a very quick question. Generally speaking, there are many different ways why a certain area could be populated by various species. I'm well aware of that. But would you say in general that evolution occurs because animals tend to evolve into niches where they don't have any competition?
Well, I think they're always trying to improve. So there's certainly, even once they get in, say like they're getting into the grazing niche. So one of the big trends in mammal evolution over the last 10 million years is the more expanse of open savannas and grasslands compared to previous things. And so you have things like antelope and bison and horses adapting to that. And in some ways, once they adapt to that habit, so obviously they're changing their physiology because grass is less nutritious than leaves. They are changing their teeth. They're changing their limb bones because they have to walk greater distances. They're no longer can hide from predators, so they have to run faster than their predators. Mm-hmm. So there's always sort of a competitive arms race, both between the same things that are sort of in similar niches, as well as there's the old joke about, how fast you have to run to escape the bear. You just have to run faster than the other guy. So again, it's sort of true with the gazelles and the zebras and things. So there's, who is ever the easiest prey of the big predators, that's, so if you evolve a better escape mechanism. So yes, things are all, but I think what you generally said was true, and I sort of now lost the thrust of where we're going with that. But so the animals are always evolving. The problem, of course, in today's world is the climate is changing faster than they can evolve to adapt. So there have been many periods of global warming and global cooling over the past millions of years. But the pace that it occurred, the rate of change of the climate is maybe 100 times faster than what it was typically going through many of these previous changes. And so the animals are facing much more rapid change. And so some of them just can't handle it.
We have one question on chat that said, when were human bones found?
Well, in Florida, in the site I mentioned near Vero was the first documented find of actual bones of humans. And that was in around 1915, 1918. At that time, it was very controversial and made headlines around the world, the so-called Vero Man. Most of the archaeologists at the time did not think that modern-looking humans coexisted with big Pleistocene mammals. And so the prominent archaeologists at the time said, those were found by paleontologists who don't know what they're doing and are just sort of burials that were intrusive. More recent geochemical analysis has demonstrated positively that those bones are Pleistocene in age. So that's about the oldest actual bone evidence of actual bones is roughly in the 11, 12,000 range in Florida. There's a few that are older in western parts of North America and South America, and then you get artifacts going a little further back, but not actual bones. Now, obviously, things are much different in the old world where humans and hominids go back much, much further.
Thank you very much. We've got another group apparently coming in. I was told at 11:15, so this room was scheduled back to back with this one. So the Cox Cable is coming in to talk about new cable channels.
New cable channels.
Very important.